This is sun. You might remember it from the time you were outside before COVID. All life forms need energy, and simply put, sun is one of the primary energy providers of life, other than few thermal vents deep in seas or natural thermal geysers. Sun sends some 173,000 terawatt of powers towards the earth. Taking banana for comparison, human produced 21,000 terawatts of power in year 2018. Our ecosystem do not use all of it. Some is reflected back into the space from atmosphere, and then some from clouds, and then some from Earth's surface. Most of the radiation absorbed by the surface is radiated back into the space. Back to the topic at hand, how to use this energy sun is giving us. Sun sends out light waves which hits earth during daytime. This light includes ultraviolet short wavelength, visible or infrared wavelength, or long waves on right. This light hits the surface of solar cells and produces electric charge differentials, which generate electricity. But how is charge differential created? To clarify, let us turn the panel and look at the cross-sectional view of it. As you see, there are three layers here, sandwiched in a solar cell, which mostly is made of silicon, while the top and bottom layers are doped with impurities. Also notice that the width is not same for three layers. Let's look closer. Pure silicon is a semiconductor. Boron atom has one electron less in second orbit, which is 3, while phosphorus has some extra electron than silicon in third orbit, which is 5. So literally silicon can be mixed with phosphorus and it will have more electron ready to move around, which means it will easily be negatively charged, hence called N-type. Similarly, silicon can be mixed with boron and it will have extra vacant space, that is positive charge, ready to move around, which means it will positively charged, hence called P-type. Good. Now back to our sandwich. Ultraviolet light will be self-absorbed by the upper layer, hence generally this is kept thin. Infrared can pass through, hence bottom layer is thick. But if the light is just in right range, an electron will be knocked out, which will move upside to N-type, which will create a hole, means positive charge, that will move downward to P-type layer. Now we have upper layers with electrons and lower layers with holes. In other words, charge differential. Good. Now all we have to do is connect these two sides, N layer and P layer, with wire, and we have created electric current. Yay for the science so far. But the engineering part is not completed yet. A single cell in itself is pretty useless, but we can wire them together to get useful voltage. This is just the basics of solar cell, most commonly used commercially. There are other type of solar cells too, like thin film solar cells made from cadmium or copper, or group 3-4 solar cells with each its own trade-offs and specialized usage. There is also the topic of electricity storage and transfer, which we would cover maybe in another video. Till then, bye for now.